Hello everybody, I'm Alexei Krabor, the organizer of SF Scala. Here we're on location at Fauna, and with us we have Evan. Evan is the CEO and founder of Fauna, and we actually met, I would say, about a year ago or more, and talked about Fauna as new kind of database. And now it opens its doors for the SF Scala meetup for the first time. So we're really excited to be here, and I'd like to catch up and see what's new with Fauna.
Thanks, Alexei. Yeah, we moved into this place about 2 months ago. Before that, we were in the top floor of a converted Victorian near South Park.
Yes.
That's where I first met you. So before that, we were in my basement, but that was a long time ago. But yeah, we're 14 people now, preparing for our public launch of FaunaDB in March. Mm-hmm. So we're rolling out previews, especially previews of the serverless cloud product, and basically finishing up the business side of things with billing systems, improving tutorials, documentation, all that kind of stuff that you need to use Fauna as a self-service adopter in particular. And the database has been in production for a couple years now. In particular, NVIDIA is our biggest early partner. Mm-hmm. And they have an on-premises deployment, which is in 3 data centers, couple dozen nodes, and they've scaled it up and down over time.
So I remember you talked about Fauna, and I thought it's really a cool way kind of to use the database, right? Because it's more than a key value store, right? It's an object store. Can you talk a little bit about Fauna as kind of your core database? What does it give you more than kind of traditional databases give you?
Yeah, so Fauna is a temporal object relational consistent distributed database. Our goal is to basically marry all the kind of different query patterns you would typically use from different domains like relational, document, graph, mm-hmm. even search, analytics eventually, into a single coherent system. So you can scale that underlying piece of infrastructure and use it for all your different workloads and share data across teams, share data across data centers because it's a globally distributed system as well, and basically get back to a world where you can integrate through the database and trust that the database will be the single lever you can move when you need to scale your application up and down.
Right. And so for this, you need basically so you run everything inside the database. You run analytics queries inside the database. So you have your own DSL for the queries, which you control, basically?
Yeah, the interface is a functional interface similar to Link in the C# world. You use embedded DSLs in your application languages, and that means that your queries are type safe. You don't have to learn new syntax. Mm-hmm. You just have to learn Fauna semantics, and it's pretty functional too, in a functional programming way. And you do things like map and fold over the core database primitives and page through indexes, and you can do compute and you can do set arithmetic and that kind of thing. And ultimately, you can write a very rich query, even more rich than SQL allows, remote it to the database and trust that the database will execute it in the maximally optimal way against the underlying data. Interesting.
So I already like it, right? Because I'd like my query language to be more fun than SQL, and if it's functional, it's even better. So is it similar in a way? Is it closer to functional programming languages, right? Because the problem with SQL, it's so declarative, mm-hmm. right? So basically you kind of lose track, right, and eventually create a bunch of temporary tables, and you kind of decompose it in weird ways. So how does it feel to write like a long, complicated Fauna query? Is it going to be a program? Is it going to be like a little fee program, which is going to be basically run on the cluster?
Yeah, it's exactly like that. So you're dealing with immutable data structures and parallel computation, but the computation is explicit. Mm-hmm. Like you essentially you essentially compose the query plan in your query, So you know what the database is going to do. It's not going to change its mind and start optimizing it a different way as your data set grows. You don't have to run explain to understand which index it's going to use, because you say, these are my indexes. I want to start with them, and then I want to do these operations. I want to do this set algebra, get some results, cursor through it, that kind of thing. So it's very explicit. And that lets us guarantee a very consistent performance profile as you scale your systems up and down. You can trust that the execution pattern isn't going to change.
Interesting. So how do you feed your database, right? Like, I think there is a lot of activity in open source stacks to put together data pipelines, right? So we have Kafka feeding Spark, feeding Cassandra, right on top of Mesos. How do you compare to the SMAC stack effectively?
So, I mean, Fauna, in a way, it's a traditional relational database. It's just not SQL. So you can use it as a sink for data you compute somewhere else, but you can also keep your core business objects in it in a fully normalized way, compose them with queries, push a lot of that, especially index computation that you might do in a second system like Spark or Elasticsearch into Fauna. In terms of a source, though, because the underlying data model is temporal, you can get change feeds for any query out of the system. So you can say, like, oh, here's a distributed graph join, an activity feed. Well, what happened between the last time I looked at it and now? And you get a bunch of, rather than just a different result set, you get a bunch of change events that you can use to synchronize something downstream. So the goal eventually is to internalize all those concerns. Right now it works really well as a canonical store for fully normalized business objects, in particular social graphs, that kind of thing, or as a low latency distributed sink for stuff you might compute upstream. Like you want essentially a document database that you can index and scale because you have all this offline commutation from ML processes. Well, where are you going to put it?
Wow, this sounds really, really cool. I mean, it sounds almost like, you know, if I want to build a startup, I can take this and solve a lot of problems. So I wonder, what is your impression from customers? What are the early experiences when they take this instead of a bunch of other things we were doing? What are they saying?
I mean, like usually people don't believe it can be true because we say like your queries are isolated, like you can dynamically provision where your data lives. You can use our serverless cloud and not even think about the back end at all. And people have been so badly burned, in particular by the NoSQL movement, that they want us to show them. So we have to do a lot of work to prove that the database is sound and secure and performance is good, and show that on their data sets, look, you import it, here's the query patterns, you can replicate what you already do, but now you get all these scalability, isolation, performance benefits out of the system. And people like the interface. They're tired of SQL. It's unsafe, it's hard to reason about the performance profile. The security model doesn't work with the way people write modern applications, and like the proof of that is people put ORMs in front of all their relational databases for operational workloads. So not having to deal with that and being able to directly talk to your database again is what's the word? Refreshing.
Oh, this is really cool. So is it? So how is kind of your go-to-market stage? So you're now out of stealth, or you're doing the kind of public launch?
We're out of stealth. We have beta customers both on premises and in the serverless cloud. We're looking for more, and we're preparing for our GA launch in the next couple months.
So if somebody wants to try Fauna, how would they go about it?
Just go to the website, click the request invite link, and we'll hook you up.
And so, can you demo this at a meetup, like with a realistic application?
Yeah.
Show us how you code this.
Yeah, Chris Anderson, who was one of the Couchbase founders, joined our team recently. He's working on a serverless presentation that'll have AWS Lambda executing the compute and Fauna as the back end, and then you have a fully serverless end-to-end stack where you never have to think about provisioning, and you can do even a globally distributed dynamic application in a fully serverless model.
I will claim dibs on this presentation when it's ready, so we can show it at the meetup. Because it sounds really exciting. It's kind of it makes a lot of sense, and yeah, I mean I can't wait to see it. So thank you very much for inviting us. Looking forward to playing more with this.
Yeah,
right?
thank you.
Once we play more with this, we'll come back and ask you more questions.
Sounds good. Thank you.
Thanks, Evan. Really appreciate it.